Hello, everyone. This is basically a recap from today's San Diego C Meetup. We couldn't record that, so I'm basically having an offline recording, just kind of post-event recording, just to make sure that we have it in the channel. Uh, these are these are the slides that I've uh, presented. So let me just have it as a slideshow. Um, And so this is 5 years today, March 12th, 2024. This is the meetup fees are paid by the Qualcomm Cloud AI BU in San Diego. I'm a Qualcomm employee, though everything here is my own opinion and my own time. But thank you, Qualcomm Cloud AI BU, for sponsoring the 6 months meetup fees. If you have anything that you'd like to discuss in our meetups, feel free to do so. I'm welcoming anyone that would like to have any size of talk. Just approach me. The agenda that we had previously today, a few hours ago, was similar quiz. We have 3 questions, and then we talked about immediately invoked lambda expression, lambda function, some deep dive into some tricks and some benchmarks. And then the final one was strongly typed syntax, one of my favorite topics in C++. And we will close with NamedType library, which is again one of my favorite ones. Okay, again, thank you, Qualcomm Cloud AI BU, for sponsoring the 6 months meetup fees. We have a Dropbox link that you can use for our meetup slides. Discord, ask me for a link if you don't have one. We use it for announcement and some discussions. I have the new link sent in the meetup messaging a few days back, so it should be okay. Recent sessions would be uploaded. Hopefully by the end of this, I would upload that session as well. We have a Twitter account as DCPP Meetup for announcement and mostly announcements. And the handle for that I have for myself is Kobe_CA. I manage both handles on the Twitter or x.com. My name is Kobe. I work in the Cloud AI BU. I'm leading the user space middleware software using C++17. I had the pleasure working with Dorothy Kirk on her book, and I had appearance on 2 CPP cast episodes. Earlier today, I had this new email from Andreas Ferdi. Andreas was hosted by San Diego C++ Meetup last month. So he has a new CPP resources page. So I have that linked. So feel free to use it. Looks like a very useful one. Let's start with CPP quiz. So so I'm going to just stop sharing for a second. And just I'm going to open all 3 quiz that we used, and then we'll discuss each. Okay, so let's start just in random order. I have 3 of them. So let's start with this one. Okay, so the idea here, I'm gonna make it shorter than what we had, is virtual function being invoked by constructor and destructor. This is usually not a best practice, not recommended, simply because when B is constructed, first A would be constructed, and then calling foo, which is a virtual function, would make it 1, and then calling bar, which is here, calling foo, which is a virtual function, when the object fully constructed would be 2, and then at destruction, when B destructed and then A is destructed, we only have A, so foo again would be 1. Not recommended to call virtual destructors, virtual function in destructor or constructor. It's just confusing, not the best thing to do. It's just not what you usually expect. So that was one of the quiz. The second one was related to uh, access specifiers. Long story short, this is not going to compile simply because d.x means that d is inheriting private from a and b. b x would be private to anyone that is using d, versus class C public a and b, and x is public, so everything would be public to users of x. So it's not going to compile. And the last one that we went over was a nice a nice lookup related. Oh, basically, I didn't share the previous one. Well, let me do it fast. That was this one. So sorry, I was talking about this part where it's not compiling because dx3 d.x equal 3 is not visible because we inheriting privately from a and b. So this everything here is going to be private to users of d, which is this line d.x. But here c.x is public because class C is inheriting public from A and B. B has a public X, so everything is public to outside users of C. Present something else. The last one is the lookup that I mentioned, which is 126. Okay, so this basically lookup. The question is, when we have this static X calling foo in initialization, which foo would be used? Is it this foo or this foo? It's the inner foo. So basically, this would be 11. People ask, how do we make the outside foo to be enabled? And uh, the way to do that is qualified with colon, and basically you call the one from the global namespace, and we open compiler explorer to demonstrate that. And if you do that, if you just use colon here, it's going to call foo that returns 10, and then you can see 10. So that's basically it. Okay, so we'll continue with what we had before. Okay, so the next one that we discussed was immediately invoke lambda expression or lambda function. This is the most simplest way to have lambda functions. Parentheses is optional if you don't have any parameters, and all of these are basically the same idea. You can see in books either paren or curly braces or equal, with or without the paren, the middle paren for the parameters. It's legal if you don't have parameters. So the idea is, if I want to have some value and I want to have it initialized with some constant, I want it to be a constant variable. How do I do that? So usually what you see is I'm initializing it somewhere and then conditionally set it to one expression or the other expression, but it's not constant. So one of the things that I mentioned is that I've seen that trick many years ago by Herb Sader, and it's one of the ways to do that. It's just to call a function, but function is like somewhere that you write in the beginning of the file or some other location. It's kind of out of context. Since C++ 11, we have a better approach, and the better approach is basically have a lambda. So you have the capture, you have params if you need params, and then the body of the function, and then there is this tiny paren open close, which is basically calling the lambda. And the nice thing here is that some variable would be constant, and it's if it's short enough, not a huge lambda. This is very nicely done, and super useful. You might see people using the function lambda function definition in different line, like just before the line that call it, and then invoke it here. Also, totally kosher and uh, possible. If this this call operation is something that you feel that it's funky, not really explicit enough, or people might miss it. Invoke, some people would advocate for using student invoke. Oh, I'm missing a colon here. Student invoke, that would be more explicitly done, but it all boils down to the same thing. I mentioned student invoke and student apply, two different that you might be using. Uh, just invoke is what we have here, which is totally fine. Then I mentioned that we have some from CPP stories. We have this four snippet that Bartek had in his blog post, and I have a link for that. It's all basically kind of the same. The question is like, so the last two in here. Oh, sorry. The last two are basically uh, uh, calling the lambda. So the last two are lambda. The first two are not. And the question is like, what is creating more temporaries? Someone mentioned that whoever is creating more temporaries would be smaller, but you can see that immediately invoked expression or lambda expression is uh, the third one, which is not taking a lot of time to execute. This is Clang 8 on O3. Maybe newer compilers would create a newer and a better uh, code. So just FYI. Then I'm linking the blog post from Bartek on CPP stories, and there is another very useful, in my opinion, Medium article from a few weeks ago, using and growing with lambdas, that also talks on is talking about student invoke versus just having the paren. So feel free to read that. It's a very useful and I think worth the reading. The last thing that we talked about in this session was strongly type syntax, one of my favorite one. I think it's very useful in terms of less error-prone code and not making mistakes. So the whole idea was based on a nice Stack Overflow question that I'm showing here, and it just didn't compile, and people asked about it, and I'm going to show multiple slides about how we can make it into a compiled program. I'm mentioning that Bjarne had a CPP, a C++ session 2012 about strongly type def. Remember, the type def are not creating new type; it's just renaming or an alias. It's not a new type. So this we need to do some extra work in order to get that into a new type. So this is something that the author of this specific strongly typed system decided there is a unit with meter, kilogram, and seconds, and then there is a value, the struct value that takes the unit as a tag, and then the value itself is being kept as a double. And then there's an alias to meter. Meter would be 100, second would be 001, and then speed is 1, which is meter, and then seconds minus 1. This is how the author decided to differentiate between the different units. And then the author also created a user-defined string literal, which I explained in detail in the session about the underscore s and underscore m, which is what you need to do in order to have it in the strongly typed, user-defined strongly typed. And this basically returns the value of a specific uh, unit. It can be a second, can be meter, and then there is a code that actually takes a meter divided by seconds, and there is a speed, but it doesn't compile. So let's first talk about pros and cons for the strongly typed approach. Cannot accidentally mix types, prevent errors, it's less error prone. I can overload functions. I discussed that in detail about overloading functions on different types. Instead of having integrals, just having integrals is not enough. I kept bringing chrono as an example. Instead of having integrals to define seconds or milliseconds, you have strongly typed uh, uh, elements or types that actually you can really mix and not do the right scaling of the values accordingly. The problem with strongly typed approach is that you need to define all kinds of operators. If you want to have plus, minus, division, all of that needs to happen. Uh, uh, needs to be written by the author. It's not you're not getting it from the type system for free. You actually need to write that. So this is just a zoom in to the parts that I would like to discuss. So this is the first part that I showed in the previous slide. This is the previous one was the meter, then the speed 1, 0, -1. And they just kind of zoom in into the underscore s, which is the second, getting a value of a second from a user-defined literal. Now it doesn't work. It doesn't compile. The first compilation is pretty lengthy, and I explained that adding a const expr to the constructor to the explicit constructor value fix the first one. The second one is unable to find underscore m, and I explained that this is kind of weird because we do have the underscore m long double, but it still complains it doesn't have the operator. So the problem is that we don't have the right operator uh, type. We have long double, but if you see here, we actually have an integer. So if you look at CPP reference, you can see that unsigned long int is one of the things that we could use in order to receive not a double, which is double precision, but an integer. So if I'm adding another m with a long d, and I mentioned that maybe template can help here, but we're not using templates here. We're just using explicitly unsigned long. This solves the second compile error. The third one, which is the final one, is we don't have a divide operator or division, and this is because we have different units. Value of unit 100 is not the same as value unit 001, and even if it was the same, we don't have an operator that actually defined to get that compiled. So what we need to do is basically define such operator that is taking two values of unit with m1, k1, s1. We have 6 different template parameters, non-template type parameters, m1, k1, s1, and m2, k2, and s2. And how does it work? It works in the following value of unit m1 minus m2. This would be 1 minus 0, which is 1, and then 0 minus 0, which is 0, and then 0 minus 1 would be -1, which is exactly what we need here to denote speed, because it's 100 meter divided by 9.8 seconds, and we get this speed value, which is exactly what we need. And this is pretty awesome. There's another angle to this Stack Overflow question, another solution that is kind of based on similar to what we have with integral constant, but with a value. So you have t for the value, and n would be for tagging. So I explained that this is very similar. We have the operator plus that is defined, so we can have meter plus meter. And in this case, the author decided to tag things differently or define things differently, like strongly type that for double 0. So 0 would be meter, 1 would be second, and 2 would be speed. So it's a different way of tagging. The important part is that you build your solution and then creates the relevant operator in order to get that useful. So the types looks very natural as other types. Integral constant, since I already mentioned that, this is a way to take an integral and create a real type out of it. So int and then 2 or 4. 2 and 4 are not the same types. You can see here is static assert. Used a lot for tag dispatch, which is outside of the scope of this session. Very useful to have, especially in generic programming. And we ended with NamedType. NamedType is from Jonathan Bucera. Fluent : is the namespace. A very useful unit-like or strongly typed library, which I'm a big fan of. I using it a lot. And here's an example. We're using meter, tagging it with struct meter parameter. The meter parameter struct is something that maybe not a lot of people know about it, but it's very useful. It's meter parameter is just a tag. We don't define it, just tagging it. The nice thing about it, beside the fact that meter will be unsigned long, we have addable and comparable. So it has a CRTP-like system that allows us to compose all of that features. And then meter is basically addable, so I can have M1 plus M2, as you can see at the bottom of the code in main, line 43. And I also have a string literal, so I can have 15 underscore meter, 17 underscore meter, which return a meter, and I can then do M1 plus M2 and get 32 as a result of adding these 2 meters. And I can have an alias of name type of meter with a tag of width and a tag of height, and then have a width and height. And I'm not going to mix width and height. And I can have a rectangle with this 2 variable meter width and meter height. So that's super useful. And I suggest you check it out if you're not familiar with NamedType. It's a very useful one. So people asked about the performance and compile time and runtime. So obviously everything that is template you would pay in compile time. How much you need to measure. People sometimes would like to pay on compile time versus runtime, but you can see that this whole M1 plus M2 is compiled to move of 32 to EX and then return, and that's basically it. That was my pretty much recap. It was a 55 minutes, and I just squeezed it to about I believe 30 minutes or so. Thank you everyone for watching that. Hopefully next time we would have everything done correctly with the recording. Take care and have a good day.